So when you're asked to solve an equation for a variable, what does that actually mean? It means to set the variable equal to everything else. It means that the variable is isolated, and it means that the variable is in the numerator. So let's try to solve an equation for a variable. In this case, let's solve for n. So we know that n is in the numerator, but it's not isolated. So what we're going to do is set it equal to everything else in the equation. So the first thing that we'll do is divide by r and t. So now we're left with n equals pv over r t. The equation is now solved for n. So now let's try to solve this new equation for t. So first of all, t is in the denominator. We want it to be in the numerator. So let's multiply each side by t. Actually, erase that. So times t, which will cancel out on this side, times t over here. We're left with t times n equals pv over r. So n is in the t is in the numerator now, but it's not isolated. So we'll divide both sides by n to isolate t, which will leave us with t is equal to pv over r times n. So the equation is solved for t. So now let's try to solve this equation for v. So the first thing that we'll do is multiply each side by 2 in order to get rid of this fraction, which leaves us with 2ke equals m v squared. Next thing we'll do is divide both sides by m, which leaves us with 2ke over m equals v squared. So v is isolated and in the numerator, but v squared is not equal to v in the same way that 2 squared is not equal to 2. So what we'll do is take the square root of both sides, which leaves us with radical 2ke over m equals v. So the equation is now solved for v. But let's take this new equation and solve it for m. So not only is m in the denominator, but it's also inside of a square root. So the first thing we'll do is square both sides to get m out of the square root, which will leave us with 2ke over m equals v squared. Next thing I'm going to do is multiply both sides by m to cancel it off of this side, but also put it in the numerator on that side, which will leave us with 2ke equals v squared times m. So now the last thing that we'll need to do is divide both sides by v squared to isolate m. So now the equation is solved for m. Okay, so let's try a problem using the distributive property. So we'll try to solve this equation for z. So when you look at this equation, z is in multiple places in the equation. What we want to do is use the distributive property to only write down z one time so that we can isolate it. So we know that from the distributive property, we can rewrite this equation. We can take z out of each of these expressions to make z times a plus b plus c equal to 18, because z times a is equal to az, z times b is equal to bz, and z times c is equal to cz. So we've written down the same thing, just expressing z only one time. So now to isolate z, we'll divide both sides by this expression, a plus b plus c, which is the same thing as one unit. You could actually write down a plus b plus c equal to one variable if that makes it easier, which would make this equation z times y equals 18. Divide both sides by the variable that we've made, which would leave us with this equation. But this and this are the same thing. We need to remember to replace y with what is actually there, the original expression, which would make z is equal to 18 over a plus b plus c. Okay, so let's try one more equation using the quadratic equation. So let's solve this equation for for y. So in this case, trying to isolate y on one side of the equation is not going to lead us to any good answer. We'll have to recognize that this is the quadratic equation, or this is a quadratic expression, and use the quadratic equation. So first of all, we're solving this equation for y, so we can go ahead and simply replace this x variable with y. And simply plug in numbers to find what y is equal to. So what we need to recognize are the coefficients in this expression. This is a is equal to 1. This is b is equal to 8 in this equation, and this is c. So when we plug in numbers in the quadratic equation, y is equal to negative b, so negative 8 plus or minus the square root of b squared, so 8 squared, minus 4 times a, in this case a is an understood 1, times c, and this c is 16, all over 2 times a, which is again the understood 1. So now we go on to solve this. Negative 8 plus or minus the square root of 8 squared is 64, minus 4 times 1 times 16 is 64, all over 2 times 1 is 2. So y is equal to negative 8 plus or minus the square root of 0, 64 minus 64 is 0, all over 2. So negative 8, or square root of 0 is 0. So the negative 8 plus 0 and negative 8 minus 0 is the same number, so we'll only end up with one answer in this case. Negative 8 over 2 is negative 4. So our answer is that y is equal to negative 4.